In this problem, you are being asked to find the limit as x approaches infinity here of the given equation. Whenever someone's asking you about the limit as x approaches infinity, positive infinity or negative infinity, they're also asking you about the horizontal asymptote. So what is the long-term behavior of this graph? So all those things mean the same thing. Limit as x approaches infinity. This time, previously in my other videos, I showed you the quickest way possible using leading behavior. In this example, we're going to do sort of the by hand method that is often required when you're taking an actual test in class usually. On an AP test, you're probably going to be able to use the leading behavior. But oftentimes in class, you're asked to show this by hand. And so what we do in these situations is we are going to divide by the highest power of x. Divide by that dominant term is what I call it, the highest power of x in the entire equation. So as we come through this problem, our highest power of x is going to be x to the fourth here. It's the highest power of x over the entire equation. Bigger than x to the third, bigger than x squared. So when you're writing through this problem, you would write out, and if you want full marks, you always got to keep this limit statement coming with you. And you write out x to the fourth and you divide that by x to the fourth. Plus, and then you take that second term, x to the third, and divide that by x to the fourth. And then from there, we get 12x to the third, divide that by x to the fourth, and then take the 128x squared and divide that by x to the fourth. The one thing that they will let you use on this is a little definition they usually give you when you're doing this section, which is the limit as x approaches infinity of 1 over x goes to 0. Basically, what this is saying is sort of what I refer to as bottom heavy. So anytime you get into a situation where you have a number over x, or where the largest power of x is on the bottom, this heads to 0. So notationally, how you can come back through this is they really will let you sort of come back through and say, okay, x to the fourth divided by x to the fourth, that's going to give me 1. Here, x to the third is essentially canceling out all these x's on bottom. So we really have a 1 over x scenario, which is exactly our definition here. So this would be plus 0. So you can kind of draw an arrow through and say that goes to 0. We end up in that same situation, the x to the third and the x's all cancel here. 12 over x, again, that whole thing is going to head to 0. So then we're looking at divided by 0 plus, and while it cancels x squared, only cancels 2 of these down on the bottom, this definition holds down here whether it's the limit as x approaches infinity of 1 over x or 1 over x to the fifth. Anytime that it's 1 over a number, an x to a power like that, it's going to be headed to 0. So this piece is also headed to 0. And so what you get out of here now is a bunch of numbers, and when you clean that up, you would get on top 1 divided by, and then on bottom 0. In this situation, what you want to do is anytime you end up with 1 or a number over 0, this is always telling us that this thing is headed to infinity. Because 1 divided by 0, 0 can go into 1 an infinite number of times. And so this thing is going to be headed off to infinity. That's a y value, so y is headed to infinity here. It's also telling us that essentially we have no horizontal asymptote. There's no long-term behavior on this. No singular value that we're headed towards. So when we get out infinity as an answer, we know that it's going to be no horizontal asymptote. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.